In this video, we are going to apply the factor and remainder theorems and then use polynomial division to find all the zeros of a given polynomial function. For our warm-up today on page 65, I have two questions for you. I'd like you to pause the video and answer as much as you can from both questions. Okay, you should have something written down for number one, and the first thing I hope you wrote down is that you can use the graph of the polynomial to identify zeros. You can then use those zeros to write factors. After dividing out the zeros, I spelled polynomial wrong, you can rewrite the polynomial in factored form and solve. And that is exactly what we are going to be doing for number two. Hopefully for number two, you notice that the graph contained two zeros. As a reminder at the top, it does say, oh, it doesn't. As a reminder, this problem is pretty much the format of your exit ticket. So you need to be able to take this graph and notice there are two zeros, one here at -1, one here at 4. So we have two choices. For the one at -1, we could divide out x plus 1. For the one at 4, we could divide out x minus 4. It is really your decision. I'm going to divide out x plus 1, and I'm going to use long division. I'll use box division in the next problem. So we've got x plus 1. Ooh, that is wiggly. X to the 4th minus 3x squared cubed minus 2x squared minus 6x minus 8. And the first thing I'm going to do is have a division thought. I'm going to think x to the 4th divided by x is x to the 3rd. Step 1, have a division thought. Step 2, multiply back. Step 3, subtract and bring down. So I'm going to change my signs. And -3 minus 1 becomes -4x cubed. And I'm going to bring down the -2x squared. Now I'm going to have a division thought. Why do I keep that to make it 4x squared? I'm going to multiply back -4x times x, -4x times 1. 4x squared, sorry. I'm going to subtract and bring down. And that gives me 2x squared, and I'm going to bring down -6x. Repeat. 2x squared divided by x is 2x. Multiply back 2x times x, 2x times 1. Subtract and bring down. So -6 minus 2 is -8x. Bring down the -8. And my last division thought is going to give me 8. And that when I multiply back, 8 times x is, oop, that should have been a -8. Oh, there we go. -8 times 1. And when I subtract and bring down, I get a remainder of 0. So the first thing I'm going to do, because I am looking for all the zeros, is I want to make sure I don't forget the one that I used for the factor, is I'm going to write the factorization of f of x. Okay, now I'm going to take my quotient and I'm going to group it. So from the first two terms, out comes x squared, and we're left with x minus 4. From the second two terms, I am left with, take out a 2, and I'm again left with x minus 4. So now I'm going to bring down this factor, and I'm going to set it equal to 0 at this point because I am looking for the zeros. Now I want to pause for a moment and talk about f of x. F of x, I know, has a degree of 4. I can see that in my standard form, right? Let's switch colors. This nice foamy green. I see we've got a degree of 4. I'm expecting 4 zeros. From the graph, I see 2 real zeros, 1, 2 real zeros, and they look like single zeros because I see a change in concavity, but it kind of happens down here. So I'm thinking my other 2 zeros must be imaginary. Well, sure enough, there are the two zeros I saw from the graph. -1, no surprise about the 4. But now I've got x squared plus 2 equals 0. Let's subtract 2 from both sides. X squared equals -2. When we take the square root, we're going to get x equals plus or minus I root 2. So there, if we were going to list out the 4 zeros, -1, I root 2, negative I root 2, and 4. Here are my 4 zeros. You can write plus or minus I root 2, that's fine. I just wanted to physically get for there to be 4. We're going to spend the rest of our time together doing 4 problems extremely similar to this. Okay, on page 66, there are 4 equations, and the directions say find all the zeros for f of x. If the problem factors, factor it first. If it does not, use the graphing calculator to get an integer. That's like a nice, clear crosses on the mark line, on the mark 0, and use that to divide. So number 1 has 4 terms, but it doesn't group. If I take out an x squared from these 2 terms, I'm left with x plus 3. I cannot take out a factor from this second set and get x plus 3, so I'm going to have to use my calculator. You can see I've already got the graph here, and I see there are 3 real zeros, 1, 2, 3, and that's awesome because this is 3rd degree, and I know I'm not going to be dealing with any imaginary numbers. But only one of my zeros is an integer 0. That integer 0 occurs here at -1. So I'm going to divide out a factor of x plus 1. Now I see an integer 0 here. It might be 1.5. I don't know. Maybe this is -2 point stuff. I don't know. I'm sure that the one in the middle here is -1. So I said I would do the box method because we did it before. And at this point, guys, you really should pause the video and try these on your own, unpausing as necessary. So I'm dividing x plus 1, and we've got x cubed, we've got 3x squared, got 2 more, -3x, and -5. Okay, here we go. X cubed, this is going to be x squared. This needs to be a 2x squared. This needs to be 2x. This needs to be 2x. This needs to be -5x. And again, I know this has to divide evenly. Make sure you're still moving from left to right, though. And check. And so I am left with x squared plus 2x minus 5. And I'm going to set that equal to 0. Now, I immediately notice this does not factor, and that is sad. But the good news is that A is 1 and B is even, so we have a good candidate to complete the square here. Let's do it. So we're going to have x squared plus 2x plus space equals 5 plus space, because I added 5 to both sides. B over 2 squared is 1. So now the left side is going to become x plus 1 squared, and the right side is just going to be 6. When I take the square root of both sides, I'm going to have x plus 1 equals plus or minus the square root of 6. And that gives me those 2 zeros that weren't so beautiful on the graph. I mean, these are real numbers. They're just not nice. And I don't want to forget -1 because it does say find all zeros. And we'll see that hiding under this little box are those 3 zeros. Either way to write it is sufficient. You can separate them or you can keep them together. Pause the video and try to find a good 0 for number 2 and divide that out. Okay, I see 2 here. I see a -2 and I see a 1. So I think I'm going to divide out the x minus 1. I could also have divided out x plus 2. It's really just preference. I use box here, so I'm just going to alternate. I'm going to use long division next. And I'm going to do my division thoughts out loud, but I'm not going to write them down. So I've got x to the fourth divided by x is x cubed. X cubed times x cubed times -1. Subtract and bring down. So now we're going to have 2x cubed plus 2x squared. Have a division thought, 2x cubed divided by x is 2x squared, and we're going to multiply back. We're going to subtract and bring down. Gives us 4x squared plus 4x. 4x squared divided by x is 4x. Multiply back. Subtract and bring down. Gives us 8x minus 8. And again, we know this divides unevenly because we got the 0 from the graph, which turns into a factor. So 8x divided by 8 is just 8. And then we end up with 8x minus 8. And there is no remainder. Now, when I look at my quotient, this one is going to be much more pleasant because it's going to group. So we've got x cubed plus 2x squared plus 4x plus 8. I can see if I take out x squared here, we're going to get x plus 2. And if I take out a 4, we also get x plus 2. That's great news. So we've got x squared plus 4 times x plus 2. When I solve this, x squared plus 4, x squared equals -4. Take the square root, that gives us plus or minus 2i. This is going to give us -2. And then we had the 1 that we used as our factor. We don't want to forget that. And those are our 4 solutions. And hopefully under this box, yep, there they are. Okay, I want you to pause the video and take a look at number 3. You should have had a chance to realize that number 3, you don't need to pick up a calculator for. It will factor. There are 3 terms here. And the powers are 4, 2 tells me I can set up factoring x squared, x squared. And I need 2 numbers that add to -5 and multiply to 6. So -5, let's see, if we use -6 and +1, that will add to -5 and multiply to 6. Set each factor equal to 0. And from the first factor, we get x equals plus or minus the square root of 6. Here, subtract 1 from both sides. Take the square root, and we just get plus or minus I. And those are our 4 solutions for our 4th degree polynomial. Now, number 4 looks scary. And you see that my hint here is to graph it on your calculator. If you don't have a TI with you, please pause the video and open up Desmo's calculator in another screen. If you have graphed this correctly, and do not continue the video until you've graphed it, you will see the following. You will see a beautiful graph that looks like this. And you don't need to see the top because we have a 4th degree polynomial. Uh-oh, no. There it goes. 4th degree polynomial means we should have 4 zeros, and I can see them, and they are all nice integer zeros. So I've got -4, -3, 1, and 2, and that's it. I'm done. I'll do anything else. Those, I see them. If you don't believe me, you can go look at the table. Go to second graph, and on the table, you'll see -4, 0, -3, 0, and then there will be like more numbers, and then 1, 0, and 2, 0. So there are only integer zeros, and we can see them on the graph. For homework tonight, and For the rest of the class period, you're going to work on page 83. They're going to work exactly like these three. The only difference is I'm not providing you with a graph. You can use Desmos or you can use your TI to get an integer zero if you need to. But my suggestion is you start by looking at the functions. So let's just take a moment together before we're done and just examine these 6 equations and see if any of them factor. Pause the video at this point and make decisions about what factors and what doesn't. Okay, you should have had a moment to look at them and realize that, you know what, number 6, number 24, it groups. You should group it. 25 does not group, so we're going to need to look at a graph to get a 0. When I look at number 26, it also groups. Now, 27 is 5 values. Because there are 5, immediately I'm going to need to graph to get a 0 and divide it out. And then I hope that what's remaining groups. If after I divide out that first 0, the 4 terms do not group, I will need to divide out a second x-intercept. When I look at number 28, it's going to factor just like number 3 in our classwork. And again, I've got way too many terms here in number 29. I'm going to need to graph 29 to get a 0. I'm going to slide the page down so you can see the answers. I do expect there to be the same amount of work as we had for our 4 classwork problems and our warm-up problem.